This is section 5.1, part 2. I was explaining why these power rules work. If we look at the rule number 3, here we have two things multiplied together. They do not have to have the same base, and often they won't, raised to an exponent. Now, not having the same base means I could have a 3x where I would not be able to combine them. Whereas if I had two numbers, I could use order of operations and get it done. This is more for when we can't multiply things or we can't simplify it any further. What this says is you take that outer exponent and you put it on each of the ones on the inside. This is, in the English language use of the word distribute, it is distribution, meaning you take this and you hand it out to everyone. Mathematical distribution means something else, so I tend to be pretty careful about that, but English language usage, it works. So let's look at this. Okay, so let's say I have x, y to the third power. What this means, by definition, is xy times xy times xy. Now, one of the things we know about multiplication is that we can rearrange these things all we want to. So this is the same as x times x times x times y times y times y. Here I have three x's multiplied together, so that's x to the third, or x cubed. This is three y's multiplied together, so that's y cubed. Our definition, our property says that I should take this exponent and apply it to each one, and that's what happened. I got a cube and a cube. Okay? Now, property 4 is very, very similar. It says that if you have a fraction raised to an exponent, and it's important that those parentheses are there. If we have the exponent on the outside, we get to place it on each one. Okay? So let's just say we had x over y cubed. This means x over y times x over y times x over y. And then by the definitions of multiplication of fractions, you would multiply straight across. Here you have three x's multiplied together, so that's x cubed. And then you have three y's multiplied together, so that's y cubed. So I wanted to make sure you understood that these things come out of some place. Okay? We're going to be talking about simplifying using these power rules. A simplified expression will have no parentheses left and will not have any repeated bases. Okay, so I can't have x to the fourth and x to the fifth in there because that won't be simplified. It's a repeated base. We're going to be adding a little bit more to this in 5.2, but this is good for right now. Now, as I'm working these problems, I've written down our rules on a note card here so I can just drop it and we can refer to them. Okay? The printouts, they go down in columns. So I'm going to start right here. T to the 8th times t cubed times t to the 13th. What we have here, if we look for pattern, I'm looking for things that are multiplied, and I've got that. I have the same base all the way across. That's going to be a very important thing to notice. Okay? My property says that I keep the base and I add the exponents together. So I'm going to be using property number 1. I'm going to mark these as best I can. And I'm going to write out every step. You are going to end up working some of these steps in your head. This is the same as t to the 8th plus 3 plus 13. And you add that up and you get t to the 24th power. You can, of course, write out 8 t's and then 3 t's and then 13 t's and count, and you would get 24. It's not something I recommend, but it works. Okay, so let's look at this next one. 3 to the 6th times 3 to the 7th. Don't let the number mess you up. Okay, there's a very common mistake here I'm going to talk about in a second, but your bases are exactly the same. Just like we had up here. We didn't do anything to the t. We just kept it the same. We don't do anything to the 3 either. This is 3 to the 6 plus 7. Okay? and this is property number 1. So this is 3 to the 13th power. Okay, this is not 3 times 3, 9 to the 13th power. That's not true. Okay. I do want to show you one thing about where to find your exponent buttons on your calculators. If you have this kind of calculator, you have, they call this a caret, and it's directly diagonal from the 7. And if I wanted to enter 3 to the 13th power, I'd hit 3, my exponent button, 13, and I get that answer. Now, like I said in a previous video, I forgot to grab one of our classroom calculators, but I do have a printout. It's not very high quality, but it works basically the same. Directly opposite from the 7, you have x to the box, and it would work exactly the same way. You would hit 3, that box, and then 13, and then hit enter, and you would get the same answer.